This is what I want you to follow up right now. So don't worry, just be doing exactly what I am doing right now. 3s, 4s. Where is this s coming from? I just want to consider SPDF. These are orbitals. These are orbitals. SPDF. S is standing for spin, P is standing for principal. This particular one, D is standing for diffuse, and this is fundamental. And then I want to write out the pattern. By the way, I want to use only Aufbau principle right now. Don't worry about polars, that will come in the next video. Polar exclusive on the Horns rule will come in the next video. So this is the arrangement. Please learn this right now. Then we have 5s, 6x, and 7s. Then I want to move to the p orbital. So we have 2p, 3p, 4p, 5p, 6p, 7p. Done. To the d orbital, we have 3d, 4d, 5d, 6d, 7d. To the f orbital, we have 4f, 5f, 6f, and 7f. That is not enough. Now, arrow this movement from up to down, like this, this for the 3, okay? For the 3, 4 of them will catch up with this. This 3 will catch up. This 2 will catch up. This one will be alone. Have you learned how to draw this? It's as simple as A, B, C. So what is the usefulness of this? There are 3 chemical principles that govern the arrangement of elements in an orbital. How do we arrange elements in orbitals? These are the principles. The first one is what we call Aufbau principle, which you can as well call it the build-up principle. The build-up, you can see how I build up this. And the second one is some people call it Pauli's exclusion, exclusive or exclusion principle. Some people call it Pauli's, some people call it Pauli-exclusive principle. That's completely fine. And the next one is Horn's rule of maximum multiplicity. Horn's rule of maximum multiplicity. There are other names to this, but just let's keep things simple. All right, remember the interest for this video, we're going to consider Horn's rule, this particular Horn's rule. You can see, what does this rule state? This rule states that electrons will occupy orbital of lowest energy level before the higher energy level. That is the principle called the Aufbau principle. Now, the next thing you need to understand is these orbitals we are mentioning. The orbitals are S, P, D, F. What is the maximum electrons that this particular orbital, S orbital, we have? The S orbital takes maximum of 2 electrons. This takes maximum of 2 electrons, this S orbitals. The P orbital takes maximum. How am I supposed to remember this? I'll just add 4 to 2 and that gives me 6. This one, I will just add 4 to 6 and that gives me 10, or add 4 to 10 and that gives me 14. That means that electrons, the maximum electron this S orbital will take is 2. The maximum electron this P orbitals will take is 6. The maximum electron this D orbitals will take is 10. And the maximum orbitals, electrons that this F orbital will take is 14. Does that make sense? So how can we be able to find the electronic configuration of elements using the Aufbau principle? It is simple. Now you know this, and you know how to build this. It's simple. Let's consider the first element. I will just do one element, then we'll go. Then I will drop one as an assignment. Let's consider sodium. Sodium has the atomic number 11. The atomic number of sodium is 11 and the mass number is 23. Remember that this sodium is a neutral charge. For neutral sodium like this, the atomic number is 11. That means that the proton number would also be 11, and that also means that the electron number is going to be 11. Remember, electronic configuration. So we want to look for the electronic configuration of sodium, the electron number of sodium. Does that make sense? Okay, so now how do we build that? It's simple. Using the Aufbau principle, that's essentially what we're concerned about. Remember that the maximum electron this particular s orbital will take is 2, p orbital 6. Don't exceed that. Don't exceed. You can go below each of this number, but don't exceed them. Okay, let's build the electronic configuration for sodium. And we're going to be using the atomic number, which is the same thing as the proton number because it's a neutral charge, and also the same thing as electron number, which is what we are doing, the electronic configuration of sodium. So let's start with this. You consider this guy first, which is 1s. Remember, the maximum this s orbital we take is 2. Put it. It is this upper number that we're going to calculate to see, count till it gets to 11. Keep in mind, don't exceed 11. Don't exceed 11. You're done with this. This one is alone also. Consider 2s. The maximum s can take is 2. We've gotten 4. Be careful. Okay, the next one, this arrow is saying you have to consider this one before this one. Consider this before this one. Consider this before this one, before this one. Does that make sense? Okay, so the next one is this guy, which is 2p. How many? The maximum you can take is 6. So you have 6 here. Count again. 2, 4, plus this 6. That's 10. We just need only one. Only one to meet up, or to make it up to this 11. So we don't have to do it on this p again. Move to the next guy, which is 3s. Maximum this guy can take is 2, but it can take less than 2. So, and we just needed 1 to complete for sodium. So that's how we have this to be 2, 4, plus 6, 10, plus 1, 11. So this is the electronic configuration of sodium. Is there any difficulty? Of course not. And I hope you enjoyed this video. Just consider hitting the subscribe button, turn on the notification bell so that when I upload new video, receive notification automatically, and then share this video. Don't forget to like this video. Don't forget to like this video and share. Don't forget to like and share. Subscribe to my YouTube channel. Bye-bye.